operating in a oh, not sorry. Oh man, my bad. Sorry about that. So right. Okay. All right. So I'm trying to get this thing to change. Trying to get this thing to change. Give me a second. Okay. So right, you are correct. Right. So the three is the B, right? So 3 is the B because right, because 3 is the constant. No, because 3 is the square root of the constant, my bad. So how the form works from the 25x squared minus 30x plus 9. Remember the first thing I said was that the first coefficient right here, and this should, that's what I was saying right here, it should be squared, right? So the 25x squared, that's a square. So you can change that to be 5 square, and the 9 can also be written as 3 square. Okay, that's the first clue. And so when we do that to the first coefficient and the constant, then the A becomes the 5 and the B becomes the 3. And when we're doing perfect square based on what we just realized right here, based on this form is the key to everything, guys. Based on this form, we realize that the middle term, guys, the middle term is actually just 2 times that A, which is the square root of the first coefficient of the coefficient of the first term, and the B is really just the square root of the constant, and that's how we get the middle term. So the middle term is 2ab times x. And so coming back to this question now, 25x squared minus 30x plus 9. And so we have 5 squared x minus 30x plus 32. So now we realize that the middle term must represent that 2ab. So we have the 2 and the a is 5 because the 5 represents the square root of 25. And then the 3 is the square root of 9. So the middle term is what? 2 times a, which is the square root of the first one, times 3, which is the square root of the second one. And then you add back the plus 3 square. As I said, it's supposed to be square, right? So that's working out a squared, a perfect square. Um, yes, so that's a perfect square. And so we notice that having done this, wait, can I write on the screen now? Wait, any questions right now? Any questions right now? Any questions? Any questions, guys? Any questions? Okay. Any questions? I'm waiting for questions. Hmm, okay. So that's 5 square x, right? Minus 30x plus 3 squared. All right. And so to solve that, so how do we identify the perfect square? We identify the perfect square. This is the official answer. I was explaining throughout, but to identify the perfect square now, when we have a question like this, we look to see if the square root of the first one multiply by the square root of the constant. So that's 5 times 3. If when we multiply that by 2, if we get the middle term, okay? So then that's 5 times 3, which is 15, times 2, which is 30, right? So that's 30, and so that gives us the middle term. And so that tells us that, okay, and that tells us that, okay, this equation, the expression is a perfect square. But do we understand that? Okay, so one more time. We have 25x squared minus 30x plus 9. And for a perfect square, it's a perfect square when the square root of the first coefficient, so that's 5, and the square root of the constant, which is 9, so that's the constant, which is 9, and the square root is 3. When we multiply the square root of those two numbers, and how we know this, how did the mathematicians come up with this? That's why I was showing you the backdrop, which I guess when I upload it, I was waiting until I finish with all of algebra because it's one long PowerPoint. So when I upload it, you'll be able to go back and see. But the backdrop was there to basically explain how we know that this equation can be written in this way. Of course, with this being square instead, 32, and this being 5 squared. So we realize in maths that, okay, this can really be written as this, right? Can really be written as this, okay? And then we realize that, well, this the square root of 9 and the square root of 25, so that's 5 times 3. When we multiply that by 2, we're supposed to get the middle term, the coefficient of the middle term, if it's a perfect square. And that's based on observation, based on mathematicians doing a billion perfect squares. They realize that relationship, they realize that similarity. And so that's how you realize, that's how you recognize that, okay, this is a perfect square. So you get the question and you say, is the square root of the coefficient of the first term, when I multiply that by the square root of the constant, when I multiply that result by 2, do I get the middle constant? If you get the middle constant, then it's a perfect square. Let me know if you understand. All right. Okay. And then to work it out now, wait, I'm trying to get an update. Okay. To work it out now, we say it would be the 5x. We know it's supposed to be a perfect square. It would be 5x, which is the coefficient, which is the square root of the first one. So it's the square root of the first one, the square root of the first term. is us working it out. And to work it out is the square root of the first term. So the square root of 25 is 5. And the square root of the x squared is x. So the square root of 25x squared is 5x, right? And then we take the sign, that is in front of the constant. That's our rule that we should remember, that we take the sign that's in front. Okay, and so having written the 5x, we add the square root of the constant, which is the 3, and then we square that, and then that's what we get, right? That's what we get when we solve the 25x squared minus 30x plus 9. No, you can ask questions at this point. If you want me to go over that or some other question, just let me know. Let me know right now. That's also working out perfect square. So let me know, guys. Let me know if you understand that, Let me know if you understand perfect square. You understand what's a perfect square. So we were just going through what is a perfect square. How mathematicians were able to see the relationship, see how we can write it, and how we actually solve it, how we actually factorize a perfect square. So ask any questions that you have. Can I ask any questions that you have right now? Don't be shy. We're all scholars here. Any question, guys? Are we understanding? You can PM me at Rainbow PM. You can send a private message to me if you want, and you just let me know what question you have or anything. But yeah, so I'm going to just go through one more time with this example, the how we conceptualize it, how we go through the process one more time. And so we're given a quadratic equation, 25x squared minus 30x plus 9. I would say, okay, how do I find out if this is a perfect square? Right? The perfect square, where it must be, if it's a perfect square, then the coefficient of the first coefficient, right, is 5. When we multiply it by the square root of the constant, which is 3, then we times that by 2, we should get the coefficient of the middle term, which is 30. And then we say, okay, it is a perfect square. Because the thing about algebra is that not every quadratic formula will be able to work it out by grouping, by normal factorization that we looked at last week, right? Not every quadratic equation we can do it like that, where we say, okay, we'll multiply this term by this term, and then all of that steps. We multiply this term by this term, and then we get a number, and then we find another number. We find two numbers where when we multiply this by this, we get it. And if we add them, we get the middle term. So that's another way to solve quadratic formulas. But some quadratic formulas are perfect squares. That's what we're learning in math right now. Some quadratic formulas are perfect squares. And so we're going through how do you recognize a perfect square. Please, guys, please let me know if you understand how to recognize a perfect square. Just let me know. I want to know. I don't want to move on unless I know that you guys are. Okay. I'm just gonna hope you guys understand so we can move on. Right. And then wait. Okay, great. And then to work it out now, guys. To work it out, we say it's the square root of the first quadratic formula of this, oh gosh, it's the square root of the first term, right? The first term, which is the entire 25x squared, plus or minus the square root of the constant, all square. That's how you work it out. And as I said, if you have a problem knowing which sign to use, we always use the sign that's right in front the sign of the constant. And so when we work this out now, which is 5x plus 3, this might take a while, so I probably won't go through all of it because I wanted to start completing the square. But when we work that out, if anybody can work it out quickly, you should see that we get back the 25x squared minus 30x plus 9. You should see that we get that. This annotation thing is not writing very pretty. My bad, guys, my bad. But yes, you do the 5x times 5x, which is the 25x squared. Then, you know, distributive property right here, where you multiply every term in the bracket by every term in the other bracket. So 5x times 5x, which gives us 25x squared. And then we say 5x times 3, that's 15x, right? It's a good thing I started working it out, you know, because I just realized something. Annotate. Right. It's a good thing I started working it out because it's not the one, right? It's not the one, it's not the sign of the constant, it's the sign of the middle term. So we're working with the middle term. That's what I was. So it's minus. Oh my gosh. It's minus. So this is minus. Right. So that's minus instead. Sorry. So scratch that out of your head. It's the middle term, right? It's the middle term. And so when you work that out, you get the 5x times 5x, which is 25x squared, minus 5x times 3, which is negative 15x, minus 3 times 5x, which is negative 15x again, plus 9, because you know the minus and minus, it gives you a positive. And then, so when you work out all of that now, the 25x squared minus 15x squared minus 15x squared, that together gives us the minus 30x plus the 9. And so we realize that we get back that quadratic equation. Okay. Yeah. All right. I'm wondering if I should start completing the square now. Time. Given the time, right? So I won't be able to start completing the square now because you guys will have a next session in a second. So give me. So any questions? Any questions? Are we understanding? Any questions? Any questions? Any questions? Any questions? Okay. So if there's no question, then I'd like for somebody, somebody, maybe you want to write it in the chat or you want to unmute and just tell me. If you get a question, like these questions come in CSEC paper all the time. The factorization questions, perfect square questions, because actually looked at the past papers to say what kind of questions they're giving. Such. Right. So if you get a question that gives you a quadratic equation, quadratic equation, or is a quadratic expression, how will you then know if it's a perfect square? How will you be able to identify if it's a perfect square? And when you've identified that it's a perfect square, how are you going to work it out? How do you go about working it out? There are some key things to remember. So we're looking at key things to remember right now. And I feel like I need to just emphasize perfect square because in order to understand completing the square, which we'll do, I think, tomorrow or another day, in order to understand completing the square, which is the next thing that we look at, we need to really understand perfect square because completing the square has to do with changing a quadratic equation, has to do with altering an quadratic equation in order to get it to look like a perfect square so that we can work it. That's really what completing the square is. So we try to make completing the square, we actually try to make it look like a perfect square. So if you don't understand what a perfect square is or how we get it or how it looks and so on, we won't be able to really understand completing the square. So somebody can tell me how we identify a perfect square and don't be shy. Not be shy. Do not be shy. Anybody want to tell me how if you get a question, what you look out for, what you work out to find out if it's a perfect square. All right, go ahead, Jordan. Jordan Hewitt.
If the if the quadratic has no coefficient for the a term, well, the x squared term, then you find the square root of the constant and multiply it by 2. And if that's the same as the coefficient of the x term, then it's a perfect square.
Okay, great. And then just tell me now that you realize that it's a perfect square, how do you go about working it out? How do you go about factorizing it? Because that's just identifying it, but that's great, Jordan. So how do we go about working it out now or factorizing it?
Well, if it doesn't have a coefficient for the x squared term, then it would just be x followed by the sign, well, the sign for the b term.
The sign
and
for
then,
the middle term. The sign for the middle term. Okay.
Yeah.
Right.
And the square root of the constant.
Okay. And all square, right?
Yes.
Okay, great. All right. Good job, Jordan. Everybody else, just just say I understand before we close because it's 9:43 and I know you guys have something else at 9:45. So before we close, just let me know if you understood. Let me know. Or any final questions. All right, great, guys. So I'll see you, or probably just here because I don't know why my laptop giving so much issues. But if I use the video, it creates even more issues. But do have a great day, guys. I really hope you have a great day. Enjoy the next sessions and learn, pay attention and all of that. Bye, guys. Have a good day. Bye. You're welcome, guys. Bye.